Hello everybody, my name is Gurnur and I'm excited to present our project Sentiment Analysis and Rating Prediction of Movie Reviews. So this project is an integral part of our learning journey in Comp 482 and we believe it showcases the practical application of machine learning and NPL in sentiment analysis and rating prediction. So our project's main objective was to develop a system capable of analyzing movie reviews for sentiment and predicting numeral ratings. So we aim to combine advanced text processing techniques with machine learning models to achieve high accuracy in both sentiment classification and rating prediction. So we built our project using Python, harnessing its powerful libraries and frameworks. And key tools and technology we used include using logistic regression and naive Bayes, and then FastText for sentiment analysis, and linear regression for rating prediction, Spacey for text processing and similarity analysis, Vectorizer for feature extraction from text data, and Jupyter Notebook for iterative coding and testing. So our project was divided into two main parts, and I will introduce to you the first part that I did. So in the first part of our project, we started with a comprehensive data processing stage. So our data sets was sourced from Kaggle, consisted of 50,000 movie reviews. So the raw data was a mix of positive and negative sentiments, but it also contained HTML tags, special characters, and varied cases which could potentially skew our analysis. So our primary challenge was to clean this data and prepare it for our machine learning models. So we approached this by removing all the HTML tags that can show in the figure, ensuring that only the text content of the reviews was left. So the special characters and numbers were also removed as they were irrelevant to sentiment. This process of text normalization is crucial in NLP as it reduces the noise and variation in the data. So next step was feature extraction. Here we use TF-IDF, which stands for Term Frequency Inverse Document Frequency Vectorization. This technique transforms text into a meaningful representation of numbers, which is essential for machine learning models. TF-IDF helps highlight the importance of word within each document and across all documents, giving us more nuanced feature set compared to simple count-based methods. However, working with high-dimensional data from TF-IDF posed its own challenges. So the primary challenge was related to the computational efficiency and model interpretability. We addressed this by limiting the number of features to 5,000, focusing on the most relevant terms in our dataset. So we started by processing the data. This involved cleaning the review text to remove HTML tags and non-alphanumeric characters. We then applied TF-IDF factorization to transform the text into a format suitable for machine learning models. So our choice of models for sentiment analysis was driven by the nature of our task, a binary classification problem. We chose logistic regression and naive Bayes due to their effectiveness in handling binary outcomes. The logistic regression is particularly advantageous in our case due to its ability to provide probabilities for outcomes and feature that is beneficial in understanding the model's confidence in its predictions. It's also a relatively simple model, which helps in avoiding overfitting, a common issue in more complex models. On the other hand, naive Bayes, known for its simplicity and efficiency, is particularly well suited for text classification tasks. Its assumption of feature independence is a limitation, but in practice, it performs remarkably well, even when the assumption does not hold true. The model is computationally efficient, making it a great choice for large datasets. So both models also differ interpretability, which is valuable in understanding how different words and phrases weigh in determining the sentiment of a review. Through our analysis, we could identify which words were most influential in classifying and review as positive or negative. So this is a list, as you can show in the picture, which displays the top 20 words and their corresponding coefficients that have the most significant impact on sentiment classification in the logistic regression model. So the magnitude of these coefficients indicate the importance of each feature, that is the word, in the predicting whether a review is positive or negative. For example, The words with positive coefficients indicate a positive correlation with the positive sentiment. Like the word excellent with a coefficient of 6.75 suggests that it appears more frequently in positive reviews, significantly influencing the classification towards positive sentiment. And whereas the negative coefficient indicate a positive correlation with the negative sentiment. For instance, the word worst with a coefficient of -9.41, it indicates its higher frequency in negative reviews, greatly influencing the classification towards negative sentiment. So, in simple terms, this list helps to understand which words are most influential in predicting the sentiment of the movie reviews. So, words with positive coefficients are usually expressions of positive statements in reviews, while those with the negative coefficients are commonly found in negative evaluations. So, our logistic regression model achieved an accuracy of 89% with a precision of 87.93% and a recall of 90.61%. The naive Bayes model showed an accuracy of 85.41%. So we observed an accuracy of 84.56%, demonstrating the effectiveness of our pre-processing and the modeling approach. So reflecting on this part of the project, we learned about the importance of accurate data cleaning and the impact of different feature extraction techniques on model performance. The results also underscored the strengths and limitations of different classification algorithms in the sentiment analysis. So now let's move on to the second part of our project, where we delve into the model and rating prediction and similarity analysis. So my team with Lawrence will guide you through those fascinating topics.
Hi everyone, I'm Lawrence. Based on the first part of our project, we moved into integrating sentiment analysis with the prediction of movie ratings. For this session, we leveraged a richer dataset that included not only just the sentiment labels, but also numerical rating for each review. Let me show the predictive capability of our model first. We have designed an interactive system that not only predicts sentiment and rating, but also compares the similarity between two reviews. I randomly copied two sentences from the rating of 10 from the dataset, and one of the predicted rating is 9.49, which is very close to 10, and the similarity between the two reviews is 0.75, which indicate that substantial similarity of our sentence. So it's proof our model is very successfully wrong. Let's go to the wrong side. Compared to part one, we get a new dataset from Kaggle, which provide us with over 50,000 movie reviews, each tagged with its corresponding sentiment and 1 to 10 rating score. We utilize the same pre-processed dataset method, but shift our focus from binary sentiment labels to numerically ratings. So employing the TF-IDF vectorizer, we formed the reviews into feature sets suitable for regression analysis. This is our dataset before process, and this is our for after process. Next, let's go to the visualization techniques. To better understand and present our data, we employ various visualization techniques. The word cloud offers striking visual representation of the most frequent words in positive and negative reviews, highlighting the rich dark construction language used by the critics. And this one is a bar chart, delve deeper into data, quantifying the top words and giving us a clear comparison of their usage in different sentiment. The next one is the 3D plot. This plot provides an engaging and informative view of the common adjectives and negative, adding depth to our analytics. So from this chart, we can observe that in the positive adjective path, the words such as excellent, great, amazing, and so will generally appear more frequently in our comments. With higher rating, this cloud can mean that use of these positive words and in the reviews, and is positively associated with the higher ratings. In the graph of negative adjectives, the words such as bad, poor, and terrible appear more frequently in comments, with lower ratings, which may indicate that the use of these negative words is positively associated with the lower ratings. Let's go next slides. Let's talk about the model training and evaluation. In this part, we use FastTest to train a model on this pre-processed data. FastTest treats each word as a bag of character and grades. This means it breaks down the words into smaller chunks, allowing the model to capture this essence of each word and its context in the sentence. So, for example, the word cable might be broken down into n grades. This is three grades. So it's like CAP, APA, and a PAB actual. This approach helps FastTest understand and capture the semantic and syntactic properties of words, especially used for understanding the sentiment expressed in the reviews. And let's go to the right side. This is one of the problem that we faced. You can see from this picture, our accuracy is very high, but the other key metrics like precision and recall were zero. This suggests that the problem is how our model were learning from the data. So after that, we find the issue was due to the imbalanced data. To fix this, we adjust our data split to ensure a balanced mix of positive and negative reviews. After retraining, our model precision, recall, and F1 score rose dramatically, reaching above 0.91, so which indicate a well-performing and unbiased model. In this challenge, I think taught us the importance of balanced data set and comprehensive metric evaluation in machine learning. It was a crucial step in enhance our model reliability. At last, this phase of the project was particularly enlightening. It underscored the importance of diverse datasets for model training and brought forth the challenges of predicting a continuous variable. It also highlighted the versatility of natural language processing and its applications in real-world scenarios. In conclusion, our project not only successfully classified sentiment of movie reviews, but also provided estimate rating, offering a comprehensive analysis tool. Let's look ahead. We aim to integrate more nuanced sentiment analysis, explore deeper language model for rating prediction, and possibly develop a user-friendly interface for real-time analysis. That's all. Thank you for your attention. We are welcome for any question and look forward to discovering our work further.